This video is going to review some of the information we learned about concave and convex mirrors in terms of being able to draw ray diagrams and looking at where the images are created. So what I want you to do is I want you to turn to page 6 on your notes handout from the other day and go to the slide that says salt. You need to make sure that you have this information down so you know when you're asked to describe the salt of an image. You can do that by looking at these notes and knowing what you need to put. So SALT stands for size, attitude, location, and type. So basically size is asking, is it the same size or is it larger? Or is it smaller? So the image that we see in the mirror, or the image that we see on a screen that's reflected off the mirror, you're looking at the size of that in comparison to the original object. Attitude is just looking whether or not it is upright, so right side up, or upside down. So please make sure you're writing these down in your notes so that you have this information. Location is just asking where is the image located. Oops. Where is it located? Is it in front of the mirror or behind? Okay. And then type is looking at, is it a real image, meaning you can capture it on the screen, it's in front of the mirror, or is it a virtual? And that is, virtual is where it looks like it's behind the mirror or it looks like it's in the mirror. So when you're asked to look at the SALT, that's what you're going to describe. You're going to describe the size, the attitude, the location, and the type. And you can use your notes to do that if you need help to remember what they are. That's what SALT stands for. Okay, so now if we look at the SALT in mirrors, so if there's plane, concave, convex, all of those mirrors follow the same pattern. So if you're asked about what the SALT is for any of the mirrors, you can either think about it by looking at the image, or you can look at this chart. So if you turn to page 2 on your notes, where it's the table that outlines the different types of mirrors, you can add this information to it. Some of it's already there, but you can also add it as well, what that needs to be added. So in a plane mirror, the SALT is the size is the same, the attitude is upright, and I also have reversed on there, so it's upright and reversed. That's orientation. And where is it located? It's behind the mirror. And then last is what type is it? Well, if it's behind the mirror, it's a virtual image. Okay, so for concave, concave has 2 options. And we saw that when we were looking at how to draw ray diagrams. Okay, so the SALT for concave mirrors, the first option is the image is smaller. And we see that image when, we're going to go down to the location, we see that image when the image is in front of the mirror. Or it's a real image. Okay, so its location in this case, it's smaller, it's in front of the mirror, it's real, and it's upside down. Okay, so the other option for concave is when it's larger than the original. The image is larger than the original. And in this one, it's a virtual because it's behind the mirror. And the attitude of it, it's upright. So again, those ones depend on where the actual image is located. So The last one we're going to look at is convex mirrors. So convex mirrors, the salt of the image is smaller. It is upright. And it's located behind the mirror. And because it's located behind the mirror, it's a virtual image. Okay, so what we're going to look at next is I'm going to review how to draw ray diagrams. So we're going to look at convex mirrors. So if you turn to page 7 of your notes from yesterday and look at the steps for these diagrams, I'm going to go through the steps. So step 1 says, draw rays from both ends of the objects to hit the mirror and reflect into the eye. So when I'm drawing these rays, they have to follow the law of reflection. So if it doesn't follow the law of reflection, then it's not going to be, it's not going to match up. And this may or may not match up. We'll have to see how it goes. So I didn't measure out the angles of incidence, angle of reflection. I would have to draw the normal to do that, but I kind of just guesstimated. So we'll see how this works out. So first step is I drew a ray going from the tip of the image and the end of the image and reflecting those into the eyeball. And remember, for simplicity's sake, we're actually just looking at, assuming that we're seeing it with one eye. Then what you need to do is you need to extend the ray that hits the eye behind the mirror. So I'm going to extend that ray. Oops. Extend the ray. So there I've extended it to go behind the mirror. And you'll notice that then my resulting image is in the mirror. And it is going to be, oops, should be the other way. Let's try that again. It is going to be smaller than the actual. It's smaller than the actual image is, the real image is, or the real object is. So that's how you would do it. If you end up, like this one's a little bit small, only a little bit smaller, but if you end up with an image that's actually bigger, your ray diagram is incorrect, so you have to make sure you go back and check where your angle of incidence and angle of reflection are happening. Okay, so we're going to look at concave mirrors, and we're going to look at how to draw a ray diagram when it's a real image. So the real image is when the image is created in front of the mirror and you can capture it on the screen. So to do these diagrams, you're going to actually draw three rays, and it's a little bit complex, but if you follow the steps, you'll be able to do it and figure it out. So the first step you're going to do is you're going to draw a ray from the top of the image to the mirror. Okay, and if you follow the rule, what happens with the rules with these ones is when it hits the mirror, when the ray hits the mirror, it's going to reflect off and go through F. So you're just going to go through your focal point F and follow that down. That's your first ray. The second ray you're going to draw is one going from the top of the image, going through the top of the image and going through the focal point and to hit the mirror. So the rule for this one is if it goes through the focal point, it's going to reflect parallel from that ray, parallel to the axis, back. The third ray you're going to see is one where you go from the top of the axis or top of the object, and you're going to go through C to hit the mirror. So technically, this one's not going to hit the mirror because it's not going to hit. Now this point right here, the yellow, darker yellow dot, is the important part because that's where all of the rays intersect. And when they intersect, that shows that's where the actual, the real image is going to be created. So we take it, draw it on the principal axis, and pull it down so it meets. That's where the tip of it's going to be, and as you can see, the image is smaller, it's upside down, and it's in front of the mirror. Okay, so looking at concave mirrors with virtual images now. So how to draw a ray diagram to show this. So a virtual image is created when the original image is actually close to the mirror, so in front of the focal point. So again, you're going to need to use three rays to show this ray diagram. So the first ray, and you're looking at page 12 on your notes, this will step you through the points on page 12. So the first ray is you take a ray from the top of the object and go parallel to the principal axis to the mirror. The second ray you're going to use is you're going to go from C to the top of the object in the mirror and extend that behind the mirror. Let's see if I can do this. Extend behind the mirror. There we go. The third ray you're going to draw, you're going to go from F and you're going to intersect with the first ray. So I'm going to draw, intersect with the first ray where it meets up with the mirror. So here we go, and I'm going to extend that one backwards as well. Okay. So what happens is, I'm going to have to fix this right here. What happens is, you know where the object goes, the image goes, is where these two rays at the end intersect or meet, right? So my virtual image would look like this. Right here, it'd go. That's my virtual image, and it's larger, it's behind, and it's upright. So those are the steps to create ray diagrams for both concave and convex mirrors. We'll try it out, do the examples, and follow the steps on the notes to help you.